So hello guys, welcome to my channel. In today's video, we will talk about the communication mechanism in microservices. So here is an example. Client sends a request to the microservice 1 through API gateway. And for example, microservice 1 needs some data from microservice 2 to process the request. And microservice 2 needs some data from microservice 3 to process the request. So here microservices communicate to each other to process the request. They communicate over HTTP protocol or gRPC or through some message brokers. So we will see these communication mechanisms in this video. There are mainly two types of communications, synchronous or asynchronous. Synchronous communication involves a request response mechanism. That means when one microservice needs to communicate with another, it sends a request and wait for a response. During this time, the calling microservice is blocked and cannot perform other tasks. So this can be compared to making a phone call where you wait for other person to answer before you can continue the conversation. So here is an example of synchronous. Here client sends a request to microservice 1 and then microservice send the request to microservice 2 and then the microservice 2 sends request to the microservice 3. So in the meantime, this microservice 1 waits for the second's response and the second one waits for the third's response here. So the requesting service is blocked until it receives a response from the called service. So it is a synchronous way of communication where service is blocked until it receives a response from the called service. So some of the advantages of synchronous are this architecture is very simple to understand and implement. Or in this architecture, it is easy to handle errors or exceptions since the response is received immediately. And it is suitable for cases where the sender needs an immediate response. And some of the disadvantages of this synchronous type of communication is it can increase the latency in overall system as the sender is blocked until it receives a response. So suppose here is only 3 microservices. Suppose there are 15 or 16 microservices and this microservice has to wait for that much time. So that's why it will increase the latency in the overall system. And if one of the microservice is down, it can cause delays and timeouts in the sender's operation. So it is a synchronous way. Asynchronous communication involves sending a request without waiting for an immediate response. The sender sends a message to a messaging system or a queue, and the receiver processes the message independently. The calling microservice can continue its work without waiting for the response. So in asynchronous, the calling service needs not to wait for the response. So in the example here, microservice 1 sends a request to the messaging queue and the microservice 2 takes from the queue whenever it is available. So microservice 1 needs not to wait. It will continue doing its work. And some advantages of the asynchronous are reduced latency as the sender doesn't wait for an immediate response. And it supports the looser coupling between the microservices. And it is well suited for scenarios where real-time responses are not required. And some disadvantages are it can be more complex to implement as handling of out of the order messages or ensuring message delivery can be important. And error handling might be more challenging as the sender doesn't get an immediate response to indicate success or failure. Let's see some communication mechanisms in the microservices. So in synchronous, we have one type of implementation, that is request response type, which is implemented via REST over HTTP or gRPC. We can also use request response to implement asynchronous architecture. In asynchronous, we have event driven, which can be implemented using queue based brokers or topic based messaging like Apache Kafka, or we have shared database. So in the request response architecture, we have service 1 and service 2, and the service 1 requests some data from the service 2, and service 2 process the request. Until it is processing, the service 1 waits, and then after processing is completed, the service 2 sends the response back to the uh, service 1, and this communication is happens over the HTTP or gRPC. So it is a asynchronous type of request response architecture. So here is an example of order and notification service. Here a customer places an order, and it doesn't wait for the response, as a notification service process the request and sends an email notification after the order is confirmed. So it is a asynchronous type of request response architecture. So in the event based architecture, we have different services, and different events could be emitted from one service or multiple services, and other services can be consuming those events. So basically we have two types of implementation: topic based or queue based. So we have queue based message broker. In queue based message brokers, usually the messages are placed on queue, and then one service which can be deployed over one instance or multiple instances consumes those messages. When any service consumes this event from the queue, then the message will be removed from the queue. So here is an example. Whenever any message comes to the queue, it will be consumed by a service randomly, and after the message is consumed, so the message will be deleted from the queue. So for example, here suppose if the message is not consumed by any of the service, what happens then? Suppose here is the message, and it is not consumed by any of the service. So there is a concept called dead letter queue. A dead letter queue is used to collect these problematic messages, which are essentially considered as dead because they cannot proceed through the normal processing path. So when the messages cannot be consumed by any of the service, so they will be removed from the main queue and placed onto the dead letter queue. Dead letter queue is beneficial for debugging or error handling. So next we have topic based message broker. In topic based message brokers, microservices listens to the events only based on the topics. Suppose here is an example. MS1 only listens to the topic 1 event, and MS2 only listens to the topic 2 events. But MS3 listens to both of the topic 1 or topic 2 events. So if any of the event comes to the topic 1, so it will be go consumed by the MS1 or MS3 also. So if any of the topic comes to the topic 2, so it will be consumed by the MS2 or MS3 also. So in topic based, if any of the message is not consumed by any of the service, we can retry to send again, and we can set the time interval. So third, we have shared database architecture. A shared database architecture refers to a single database instance that is used by multiple microservices to store and access their data. In this scenario, all the microservices interact with the same physical or logical database rather than each having its own isolated data store. So that's all for this video. Thanks for watching this video.